So we talked about Cairo and Cairo's features. So Cairo creates provable programs, runs on top of Cairo VM. So in Starknet, we write our code in the Cairo programming language, and the Cairo programming language is inspired by the Rust programming language. That's why we had to see how Rust is written. So, and then it's compiled to Sierra, and then from Sierra it's taken down, it's translated to the Cairo assembly, and then to the Cairo assembly it's then to the machine code. So Cairo has some few differences from Rust. We are going to look about. We are going to see them, and then it can as well be used outside of Starknet, but it as well has its bottlenecks. So we saw that this is the syntax. You see, it's kind of similar to that of this is Rust actually. And then it's a Starknet smart contract. We see a trait, an interface, and then you declare these two. These two methods are very, very important. The fn, the set, and the get. We are going to see them a lot in detail. And then this is how you declare an interface in Starknet. And then this is how you declare a contract. A contract is by it appears as a module. That's why we start with the module keyword. And then when you declare this storage keyword, it's like you are declaring storage variables on the blockchain. These variables are the ones which can be changed on the blockchain. We are going to see all of that in details. So I'm just trying to summarize what it was in the Cairo programming language designed for a virtual CPU. And it was not created for the physical core stressor, but for cryptographic ones. It's very good for the cryptographic computations. And then saying making it capable of efficiently proving the execution of every program. I won't go a lot in details about that. So what to do with Cairo? Cairo allows you to compute trustworthy values on untrusted machines. And major use case is Starknet. Yeah, important thing with Cairo and why it's a lot usable in the Starknet smart contract, it's immutable nature. The memory access is immutable. Once you've written something to the memory, you cannot change it. Yeah, you cannot alter it. So that was the recap of our first session. But now today we are going to dive a bit deeper. Is my screen visible enough? Okay. So just a recap as well. We have seen this. This is how you declare. This is just a snippet of a Starknet smart contract. So we have the interface. You declare it by this smart contract interface. So an interface is you can see it in a lot of languages. Like if in case you've written some TypeScript, you can better understand what an interface means. So like an interface, you're introducing something, yeah, but then you have to define that thing after the interface. So an interface just giving you like a glimpse of that something. So and then in the interface is where we have the traits. So this is how we declare a trait. It starts with a trait keyword. This is supposed to be, I think this is supposed to be small t. Yeah, it's supposed to be small t. Sure. But it's supposed to be capital actually. And then you have to sub-reference the contract state. Yeah. And then the most important methods in a contract are the fn set and the fn get. And then the set, as the name it sounds, a set, you are modifying something on the smart contract. You're modifying something of the state on the blockchain. That's why you have to take a reference to the object. The object in this case is the smart contract. So I'm just first introducing it, but we are going to see it in a practical view. Then you have to start with, it starts with the reference keyword, and then self, meaning that it's because it's modifying the state. It has to have the self as an attribute. And then, so in this, the value which we are referencing is the T contract state, which is the actual state, which is the smart contract. And then the get, so the get is just gives us, you cannot modify anything in the get method. It just returns the state as it is of the smart contract. Yeah. So just understand them like this in case you've done your web 2. There is a post, there are two very familiar methods. There is a post request and a get request. So a set can be a post whereby you are maybe sending someone data, but then you have to attach someone, maybe you are pinging an API, and then maybe you have to send someone along with the request. You have to attach the username, maybe the age, and then the get is how you understand it from the web tool, is that you are just getting data, you're not modifying anything. And as well as I said, so after declaring your interface, now this is how you declare the smart contract. You have to Starknet and then contract, and then this is very key here. What tells, when you're compiling the code, what tells it that it's a contract is this mod keyword, then the name of the contract, and then as well I said, under this storage data block is where we declare our contract state variables. So let me say you want to change something. For example, you have number of people on your DApp, and these numbers are going to be alternating. For example, you have people who are on a call today, so you can declare that as your variable under the storage attribute here. Yeah, because it's going to be something in the state which is going to be changing. We are going to see it in detail. And then just a continuation as well. So we shall as well look at this. So now this ABI embed, that means this, whenever you see this here, it means that because these are now how can I call it? These are now methods under here. So whenever you see an implement block has started with this, it means this can be a public, function. Yeah, it can be public, it can be imported by another contract. Yeah, probably you have two modules. So let this mean when I attach this right here, it means that if in case I have another module, I can get one of the functions or methods from this. Yeah, and then now to declare your functions or methods, first for a method, it has to have a self attribute. Self meaning is talking to the contract state, in this case, which is the smart contract. And so in our interface, we saw, as I told you, an interface gives you a glimpse. Then after you come and then you define. Yeah, for people who are familiar with C codes, it's like you first as well declare something, then you come as well and define it. So in our interface, you declare the functions, and as we saw earlier on, is that we had the set now and then the get. Then we come on in detail and define what these methods are doing. These are methods in this case because they have the self keywords. Yeah. And as I said, the set, it has to have the reference because it's talking to the contract state and it's modifying the state. But for the get, does not modify the state. So it just, that's why in the set you see it's writing, but in the get it's only reading. I just want us to take keen notice of that. Yeah. Why Cairo? It creates provable programs, proof of computation integrity. Then there is verification without re-execution. This is one of the advantages. That's why Starknet, there is a scalable Starknet smart contracts and the Starknet blockchain is scalable, is that there's verification without re-execution. We are going to see that in detail. And then it's a powerful and flexible language. As we've seen, it has an immutable memory. Yeah, when you write something, you don't need to change it. It has that immutability. But then there is a way how you can work with that something without changing it. Yeah, powerful, prevents cheating and malfunction, and then keeps a supercomputer honest. So now, mostly what we know about Starknet is its ability to scale. Like Starknet has come as this solution to scale the Ethereum blockchain. Yeah. And as we said earlier on in the first session, Starknet is an L2. Yeah. So Ethereum has issues with scalability because Ethereum, you find it's handling scalability and then it's handling settlement. Yeah. So, and basing on its infrastructure, it for example, if at all there are 42, the new state in the blockchain, maybe there are 42 blocks which are written. Yeah. So in the Ethereum blockchain, all these blocks have to be independently validated block by block to the total of 42. But now this is the case net, yeah. So for Ethereum, every block has to be validated on the blockchain, yeah. Remember, everything which happens on the blockchain, every transaction has to be validated. So now, for Ethereum, if at all we now the new state, we have 42 blocks. All these 42 blocks have to be validated, and it ends up becoming robust. Yeah, hence slowness. Yeah. So now that's where Starknet comes in. So in Starknet is pretty simple. So the validators don't need to verify all the transactions. They only need to verify, yeah, the one. For example, if at all in the 42 blocks there is one block which we are interested in. Yeah. So the case with Starknet, you don't. Am I reading a message? Yeah. Okay. Okay. Sorry. I'm still saying for the case with Starknet, we are only interested in looking for that one block. Yeah. It's the only one which we need to verify. We don't need to verify all the 42 blocks. Yeah. So that's why it's fast. Yeah. And it's scalable. But for Ethereum, you have to verify block per block. Yeah. So you'll find out that the speed in Starknet is a tenth of that. Yeah. The amount of time taken is a tenth of that needed as compared to the Ethereum blockchain. Hope we've gotten that. So that's where the scalability issue of Starknet comes in. Why it's really doing a credible job to scale Ethereum. Yeah. Hope we've gotten that clearly. So I just want you to understand this. So Starknet, as we know that there are two categories. We have the optimistic rollups and then we have the validity rollups. Yeah. Now the validity proof, now Starknet is a validity proof. Yeah. So Starknet, you can understand it as what a zip file does to the file size. Yeah. So in case I have like a file which is as big as 100 MBs, and when I zip it, it can go to 25 MBs. Yeah. So you find that a good amount of data has been cut. So because of zipping. So that's the same thing Stacknet does. Yeah, in case it's just the same analogy. File compression that's the same analogy to what Stacknet uses. So validity proofs, as I said, zero knowledge proofs. So Starknet, it convinces the verifier on the layer 1, in this case our Ethereum, of a new layer 2 state without sharing the transaction details. Yeah. So it doesn't need to share everything. Yeah. So it just needs to get a verifier. Yeah. It just needs to verify a computation. Yeah. But it doesn't need to reveal every transaction which has happened on the blockchain. So in case there are about 100 transactions, it doesn't need to reveal the details of all the 100 transactions. It just needs to get to verify one. Yeah. So it doesn't make L2 transaction private. By it verifying, it doesn't mean that it's making the transaction private. Yeah. But it's just verifying that one transaction which we have interest in. Yeah. And then, as I said, it makes verification efficient. Yeah, since you don't need to verify everything. So we can we can therefore categorize Starknet as a validity proof, and then it's based on the Stacks technology, not Snacks. There are two types. It would be better for us to find them out maybe after this session. The Stacks and then a Snacks. That can be like a good assignment. Yeah, these two things are different. So Starknet is based on Stacks and non-Snacks. Yeah. And then because of the above, it's a very efficient for proving and verification because of its speed. Yeah. So because of its speed, you find that the gas fees on a DApp which is deployed on Starknet, the gas fees which are needed to pay are very minimal compared to those in maybe a smart contract which on Solidity which is deployed on an L1 like Ethereum. So these are some of the differences of the stack and then the snacks. Yeah. So for the verification, this is the route it takes. Yeah. To when it's coming, it's quantifying the verification. It takes a log squared n. So n can be number, and then the snack. So the snack it's constant. So here it beats it at this, and then yeah, so then also in the proof size, snack is better than the stack. But then our biggest advantage as the stacknet lies in the proving time, the time needed to prove a computation, to verify a transaction. Yeah. So you'll find that for the stack technology, it takes 1 time, but for the snacks, it has to take 10x. Yeah. So this is why Starknet becomes a favorite in scalability, and then it's very 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 secure. Yeah, it's very 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 secure because, as I said, it uses that analogy of the memory immutability. Yeah, hope we're on the same page. I don't want to go so fast. In case you have any questions, you can Kindly raise them. I don't want to go so fast. And then, so just imagine you are making a withdrawal, yeah, and maybe it's from an L1 to an L2, yeah. So for Ethereum, because Ethereum is our layer one and Starknet is built on top of Ethereum, so we are comparing optimistic rollups, yeah, rollups, optimistic rollups, yeah. So just a question. I think ZK ZK an optimistic rollup or it's a validity rollup? Let me just clarify that. I just want to give a clarification here. Is ZK Let me just ask Google here. I think ZK and I'm just rectifying something small here. No, no, no. ZK as well. It's a validity rollup. Because can you give me an example of mystic rollups? Yeah. Let me check. Yeah, yeah. Yeah, yeah, yeah. Yeah, yeah, yeah. Thank you so much. Yeah. So, so in this case, we are looking at maybe you are withdrawing funds, and maybe it's a DApp which is built on Starknet in comparison with one which is built on a blockchain which uses the optimistic rollup technology. So Starknet will only take 2 hours to settle this transaction. But for optimistic rollups, they take as close as to 1 week. Yeah. So in that case, they are so slow. Yeah, they are so slow in comparison to validity rollups like Starknet. So just a summary of why Starknet is optimized for zero knowledge proof tech. Has a high computing power and low gas fees. Secured by stacks as well. It's built on top of Ethereum. Cairo. It runs on a powerful language, Cairo, and then of course it has its own tech stack. Yeah. And then, as I said, in case you are settling, for example, funds, in case you are withdrawing assets, yeah, from maybe the layer two to the layer one, yeah, because since Starknet is built on top of 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 Ethereum, there are some fees which have to be paid, yeah, yeah, for validating the transaction on the Ethereum blockchain. So as I said, it takes 2 hours only for us to settle these assets compared to optimistic rollups. Yeah. And then another thing here, what's a smart wallet? Yeah, probably most blockchains you for example Celo they have a wallet, yeah, because you need something to pay the gas fees with, yeah, and and these are like custom wallets which use the tokens. For example, for Starknet, it's the stacks. Yeah. And as we shall see, we have the agent wallet. and then we have as well Bravos. Yeah. So smart wallets. Uh, so on Starknet, every wallet is a smart wallet. Yeah. So what this tries to entail is that every wallet is like like every, in case I have a computer, yeah, and then I have maybe the Bravos wallet on it. My computer is a signer, yeah, is a signer which I'm using, and it has to be when I'm using like the Bravos, and it's maybe on my MacBook. My smart contract will detect the signer, in this case, which is my device, which is the MacBook. Yeah. And then as well the contract coming from what I'm using. In this case, if it all is Bravos. So a signer in this case becomes becomes your device, the device which is having your smart wallet. Just a minute, let me just plug in my charger. Forgotten to plug it in. Thank you. Yeah, so in this case, the device which is hosting your smart wallet is the signer. Yeah, because it will have to your contract will have to detect which signer have you used. It can be a mobile phone, it can be a hardware device. Yeah. And then so we have providers like Agent and Bravos. So as I was saying, we have accounts. This is just to delve in more details in what the signer and then the account is. So the signer, as I said, is the device. Yeah, the device that signs the transactions, and then it identifies the user with a PK. PK is like you can understand it like a primary key. Yeah. So there is that uniqueness of every signer. And then an account is a smart contract on Starknet, and it holds the assets, and then it verifies signatures, executes transactions with multi-call. So account is what is it's in it's what is in the it's what the smart wallet holds. Yeah, it holds your account. So maybe we can just have okay, we are going to look at that. I would want us to some of us who don't have wallets on Starknet, we are going to have just after this small session, we are going to have a moment and then create 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 these wallets. It's just an extension, you just install it. But meanwhile, let me just proceed. So then signature verification. So this is what happens. So every transaction, yeah, when every transaction is happening on the blockchain, it has it every transaction has a signature on it, which is verified. Yeah. So while I say blockchain, there is that immutability. Yeah. So for example, if I told we know blockchain, it's that these are interconnected nodes. Yeah. So in case I've written a transaction and I've written it and it's in one node, since these nodes are connected, so one node shares the signature of this transaction, and then it shares it of this block. It shares it in another node. So this other node, which is connected to this node, copies the signature. So why the blockchain never goes off is that because these are interconnected nodes, so what happens in one node is copied into another node, like that. So in case I'm doing something, maybe I made a transaction, and then in one node, but at that time that node on which was accommodating the block of my transaction, or yeah, which was accommodating the block of the transaction. So in case that node is off, yeah, the blockchain will just look for another node, yeah, because as I shared that every node shares details, yeah. So the signature will have details such as the timestamp, yeah, of that transaction. So in case one node is off, another node can get what was in the other node and return it. Yeah, so that's why the blockchain handles things like immutability. Yeah, so you've shared you've shared a document and you've stored it, there is no way someone can come and claim that they're the ones who are the owners of that document, because in the actual sense you in the actual sense, you as a person who 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 had the ownership of that detail, because your details, your signature was recorded. So that's why there is that immutability and that authenticity in the blockchain. But back to just I was just trying to go in detail, but coming back to what we are on about signature verification. Just a minute, just plugging in my charger. As I was sharing, that the signature verification we have a single signer. So just this is going into details with the signature verification. You can have a single signer. Maybe if I have a device and it only has one, it's only holding one account, and then as well you can have multiple signers, yeah. And then signers, as I said, they can be hardware devices. Then you can recover the social recovery, and then there are things like session keys. Uh, then this we may not go in detail with it. Just trying to shed light on something about the stack. So let's proceed. So in summary, what smart wallets are in Starknet is that a wallet is the way you understand your your bank. Your bank gives you an account number. So and that account number you deposit money. So in this case, like your smart wallets are are are, are the, acting as an interface to your bank and to your bank which has the money. So now the smart wallets, they're just interfaces for us to 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 access our assets on the Starknet blockchain. And as I said, we have bravos, we have agents, yeah. And then I said hardware, so you can have your smart wallet on a phone, you can have it on a PC, yeah. So an account is a smart contract, yeah, with specific interface and supports signing transactions with different ICs. On Starknet, every wallet is a Starknet wallet. Yeah, there are no externally operated accounts. Every wallet on a transaction is a smart wallet. Yeah, is a smart wallet on Starknet. Yeah. So we are just going to have a small breather here as we rest. I just want us to do something small. We are going to install these smart wallets. So as I said, we have the agent browser extension, and then we have the Bravos. So you can just go and download. So in case you have Chrome, you can just come to the extensions, visit the Chrome Web Store. Can we guys do that? Can we install, in case you don't have in case you don't have the smartwatch, maybe you can use this moment to install the agent smart wallet or Bravos. So you just go to the Google Chrome, and then you click on those three dots. You go to extensions, and then there is visit Chrome Web Store, and then you type in the name Bravos or Agent Smart Wallet. So we can just do that for 10 minutes, and then you tell me in case you're done. Natasha, do you have that? Are we clear? I need a confirmation from you guys. Natasha, are we okay? That's really great. And then we are going to check as well at something. We are going to to so in case we need to, for test purposes, we shall get faucet. Faucet is like test money. Test money. So you are going to add a test account. Yeah, you're going to add a test account on your smart wallet. Yeah, and then I want you to, mostly you use Sepolia. Yeah, Sepolia is what is used for the test as a test net. Yeah, and then I want you to fund it with some faucets. So faucets, you can get them. I think it's Starknet dot. Let me check. Is it Starknet.faucets.com? I think it's Sepolia. Yeah, let me share the link. Starknet faucet.vessel.app. This is the best actually. Let me share it. Let me share it. So use that link that I've shared. This is going to work. Can we all try to use that and then fund our test nets? That one I know it works. And then you can just give me a thumbs up when everything is working. So maybe I can, let me try to present maybe how to do it. Okay, let me just share my screen here. My screen is visible. I'm presenting. So you just come to here, then you paste in your test net, then you can switch. whether you need the stacks or ETH, and then you just press here, I'm not a robot, and then you send request, then it will be funded. So you can just give me a heads up when you funded your wallet. So we have seen that. So now we are going into an interesting thing, the architecture of Starknet. Yeah. What's all about the architecture of Starknet? How is it? Yeah. What is it about? Yeah. What's underneath Starknet? What powers it? Yeah. Those are things we are going to look at. Yeah. And so as I said, Starknet smart contracts utilize the Cairo programming language. So there was a later version of Cairo 0, but now we are running on Cairo 1. So the Cairo is compiled down to Sierra. Yeah, it's not exactly that when you write the code in Cairo is taken to the VM. No. Yeah, so Cairo is compiled down to Sierra. Yeah, and then Sierra. Yeah, it's then compiled down to the Cairo assembly. The way you see that uh, Solidity, in case of ever written code in Solidity, it has to be compiled to the assembly. Yeah, yeah, and then from assembly, from Kazim, then that's when it's compiled to the VM itself. Yeah, and I remember, as I said, the VM is what was inspired by Rust. Yeah, so the Cairo VM wasn't written in Cairo; it was written in Rust, and some of the developments that they are doing is to make the VM directly written. Those are some of the inspiration, some advancement. They're trying to shift it to the Cairo programming language. So that's the architecture. And as I said, Cairo, it's a provable programming language. It has a syntax similar to Rust, compiles to Sierra. Sierra in full is the self-intermediate representation. Yeah, it's a self-intermediate representation of data on a compiler. And then a sequencer compiles the Sierra code to self Kazim. Now self Kazim is Cairo assembly. Yeah, probably you've heard of something like WebAssembly. So it's kind of similar to that, Cairo assembly. Then as well, the failed transactions as well included in blocks. In case the transaction has failed, it's of course it's because it's a block, it will be included. Yeah. So there are more, because I said currently the version we're utilizing is 1.0, so there are quite some improvements compared to Cairo, compared to the initial version 0. So now let's try to go to the internal modules. Yeah. So in case you have, I just want to show you how the on Starknet, what is interpreted, what goes on behind the scenes. So this right here maybe is your smart contract. You've written it on your laptop. Yeah, you've written it on Starknet. So as I said, it's compiled down to Sierra. Sierra sends to Kazim. Sierra compiles it to Kazim. Then Kazim compiles it to the Cairo VM. Yeah. Now after a Cairo VM, as I said, Starknet only looks out for, it doesn't have to check every block on the blockchain. Remember the first example that I gave? It doesn't need to cross check every every block, but it just verifies, yeah, using cryptographic computations, and then it returns through a verifier. Of course, here I'm saying that it's utilizing the validity proof, and then it returns through the verifier, yeah, that block, yeah, which is valid, which we are interested in, yeah. So it returns through the verifier that block and then the results, yeah. But as I said, it doesn't need to return all the transaction. It only returns that specific transaction. Hope I'm clear with that. So still more about that. Nothing so different. So now the verifier is what is returned on the Ethereum blockchain. Yeah, as we know that uh, Cairo Starknet is an L2, and first is Ethereum, yeah, and then Starknet. So whatever Starknet gets, after the cryptographic computations have been done and they have identified that specific block, it's being returned. Yeah. So why is Starknet oversimplified? Starknet doesn't seem so complex compared to other L2s. So Starknet uses smart contracts. Before executing a smart contract, it must be declared, as I said, and then after that it can be deployed. Yeah. So there are some nodes that we use for deployment. I've worked with. There is a node called Katana, which I'll as well work with it. Yeah. So and then there is this: a user interacts with Starknet via transactions, and then transactions must be signed. That thing is very crucial by a signer, and this a signer can be maybe your HP book, maybe something which is harboring the wallet, your wallet. That's what your signer is. So, proving, how does summary on proving compilation? So, proving compilation, the Cairo compiler is written in Rust. So, because the Cairo compiler is written in Rust, it's not written in the Cairo VM, and it's what the Cairo VM is what we are using to prove. So that's still one of the advancements they're looking at. How can we write the Cairo VM in the Cairo programming language, the Cairo compiler in the Cairo programming language? Yeah. So that's why a long-term solution is write the Cairo compiler in Cairo. That compilation can be proven. So, but though that's still a challenge, yeah, there is a solution to that, and that's why I said that the Cairo assembly is there in the middle to act as an intermediary, and it's the assembly is storing that hash. So how the proof happens is that they are comparing hashes, yeah, during the compilation. Yeah. Yeah. So they compare the hashes, and what is doing that is this Cairo assembly. The code is being compiled from the Sierra. So just felt like sharing something about declaring versus deploying. Declaring a smart contract registers its code on Starknet. Yeah. So when you declare a smart contract, it doesn't mean you have deployed it. Yeah. It's just like mm, when, in case you've written code in object-oriented programming languages, uh, an instance is just like an instance. When you create an instance of a class, it's just like you've declared. It's like you've declared an object, yeah, and you're trying to inherit something from that class, yeah, some features. So this is kind of a similar concept here. So declared smart contract is known as a contract class, yeah, and the contract class is identified by its own class hash, yeah. And contract instances can be derived from a contract class, like in object-oriented programming. Yeah. So this can be, so as I show us, just a minute. So address, these all can be instances of the same class. But what is making them, yeah, what is making different is that the hash. The hash is what is our point of interest. And the contract instance has storage. Remember, as I said, storage is where we store the 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 state variables of the blockchain. Yeah. And then a contract instance is identified by its address. Yeah, it must have an address. Everything on a blockchain has an address. Everything has an address. You can trace the address. So there is something called a universal deployer. So there is a smart contract that deploys other smart contracts. In case you have to go in depth, you'll find it, and where we shall be using things like syscalls, we shall look at them when we come to writing Cairo code. Just I think in the next session we are going to have some Cairo codes. Yeah. And as I said, the blueprint is the class hash, and then as well constructor arguments. But this universal deployer, it internally uses the deploy syscall, and then it's created by OpenZeppelin as a public good, and it's written in Cairo 0. Yeah, OpenZeppelin has some. So in case there are certain functionalities, maybe you can find like ownership, or there are some functionalities. Maybe you can import them as components, and you may find they're coming from OpenZeppelin. So it's just like, in case you've written Python code, in case I need to work something with the operating system, I don't need to write the whole operating system. I can just import the operating system as a package by saying import OS. So that's the same thing. So I can import some functionalities through components, yeah, and then I use them in my contracts. Yeah, so for now we are going to end here. So in case we have any questions, this is the time to raise the questions. In case anything you haven't understood, where you feel we need to throw more light, this is the time where you can kindly share it. So I thank you all for being on, and yeah, for me, I think we meet again on Monday, same time, 8 p.m. East African time. Thank you for being a good audience. Bye.